Alright, in this video I'm going to talk about the expansion of my solar panel project. I am looking to install more solar panels on my roof, which is going to complete my solar panel expansion on my garage roof. What I have here is 8 235 watt solar panels I purchased from the alternative energy store. Of those 8 panels, 5 more of them are going to go on my garage roof, and that's going to fill up the last row of my garage roof. So I'm going to be roughly making about 1100 to 1200 watts of power peak, in addition to what I already have. And then sitting on top of the solar panels is the side of my server cabinet that houses all of my solar panel equipment inside of it. So I'm going to go ahead and give you a view of the cabinet itself. Things are torn apart a little bit, and I got some of my tools and equipment ready to go, so I can begin the process of doing the installation. Up top here, what I have is my 3 disconnect switches. Those 3 switches are going to represent each of the 3 rows of the solar panel. The one being farthest to the left is going to be for my 4 100 watt Windy Nation solar panels that's already up there. That middle row is currently running my 6 200 watt alternative energy store solar panels that I purchased from them. So right now I can make 1600 watts of power, and that last switch, which is right there on the right hand side, that one there, which is in the off position, that one's going to allow me to add the additional 11 to 1200 watts of power that I'm going to be bringing into the system. Right now that switch all the way to the left there, that one's running on 12 volt solar panels, which are the 100 watt solar panels. Those panels are connected to also this charge controller. So right now they're currently in the number 2 position, which sends the power straight to the house, so I can grid tie the system with the other row of solar panels, which is also grid tied. So again, the number 2 position represents that right now both rows are running in the grid tied position. But if I was to switch that first one over to the number 1 position, it would then send the power to this charge controller. And as you can see right now, the batteries are currently at a charge status of 12.8 volts, which isn't completely full, but they're close. They are wired to be at 12 volts. And then from that charge controller, the power goes down to my 4 Trojan batteries, which are the TE105REs. These batteries are 250 amp hours, 6 volt batteries, but they are wired to be at 12 volts and at 500 amp hours. And again, there's 4 of those batteries there, which is roughly about 90 pounds of batteries. These batteries here, their sole purpose is mainly just to be there as a backup power supply if NIPSCO, which is my local power supply company, was to go down. Again, I could run the house off of this backup power supply, and then from there the power from those batteries goes to this off-grid inverter, which is rated to be 1500 watts RMS or 3000 watts peak power. And the batteries also are running on a float charger, which is a battery tender charger. So right now, like I said, the batteries are just staying in the float position for the most part. I'll cycle them every so often and equalize the batteries just to keep them healthy, but they're mainly there just as a backup power supply system for if the electric company was to go down. So heading back to how the system runs in its normal everyday use as far as being grid tied, that first row, or the top row of solar panels, which is the 4 100 watt solar panels, are hooked up to the 600 watt grid tie inverter. That second row of solar panels, which are 6 200 watt solar panels, are ran to these 2 inverters here, which are 1000 watt inverters a piece, so they can do 2000 watts peak. And like I said, roughly they have about 1200 watts of solar panels going to them, or exactly 1200 watts peak, which are 6 200 watt solar panels. And then up top you can see the battery status lights to show that they are currently producing power and taking power in on both of those inverters. So as far as how the power is being created, I have also in the garage these kilowatt meters, which are the inverters are hooked up to. This one here is showing 230 watts. That is in representation of the top row of solar panels as far as the 400 watt solar panels. Right now they're roughly making about 230 watts of power. This next meter right here is representative of the middle row, which is capable of making up to 1200 watts of power. Right now it's currently making roughly about 880 watts of power on that one there. And then the total creation of all the solar panels, which are the two rows, they're roughly making about 1100 watts of power at the moment, which is pretty good. Right now it's a little bit later than noon, so I am about as far as a high point in the sun, but the angle changes the sun. There's times where with those solar panels I have peaked out at about 1500 watts, so I can't complain about the total efficiency of it. And then this empty spot here, this is going to be for the last row of solar panels. I've just recently moved some things around to make this spot empty. This is where my two additional 1000 watt inverter is going to be for that last row, which again is going to be the 235 watt solar panels that were sitting over there in the corner. And as far as the inverter goes, the inverter, as far as the new ones, here's one of them. It's just sitting there ready, waiting to go and ready to be installed. But real quick, I wanted to show you one last thing. I wanted to show you my Pt2 device I have hooked up to the solar panels, which is it also stands for the energy detective. What this actually is a way of allowing me to monitor my solar panels without having to go to the garage via software or a LCD screen that sits on my kitchen cabinet. I can view it through either my tablet, my laptop, my desktop computer, or I can also view it through, like I said, this LCD screen that sits on my kitchen counter. But here's a brief view at it for right now. So again, right now the system, let's see if I can get it to the right spot. The software is currently loading up on the device itself as far as my tablet. I'm using the Wi-Fi from the home. Let's see if I can get this in there real quick. So right now the system, as far as a live view, is currently making 1100 watts of power, which is the total creation that the solar panels all combined are making. I'm going to show you one other view. This is the total status of what's going on in the house altogether after the house has consumed some of the power from the solar panels. So right now, as you can see, this is the total view, and I am currently now sending 942 watts of power out to the electric company, which is phenomenal. I can't complain about that at all. Like I said, it's nice to turn that meter backwards, and again, that's the big picture and the big purpose of the system altogether, is to run the meters backwards as quickly as I can during the daytime. Another thing I want to show you super quickly is on 6/7, the system, you can see there had the minimum month to date was 1500 watts, so at some point my system made 1500 watts of power, and again the maximum power creation is 1600 watts. So the system, in my opinion, is a very efficient system, and the buzzing noise you hear in the background is just the fans running on the inverters just to go ahead and keep the system running and cool. But other than that, that's all I got for you. I'll keep you updated as I continue to expand in the system and the new project that I have coming up with those new solar panels, but I'll keep you up to date. Okay.